Hello. In this video, we are going to look into a very important discussion, which is often asked in interviews, such as design a high availability architecture. So this is like a very generic question that is being asked in the interview question in the interviews, and it can be asked in a few various ways, such as design data resiliency architecture or design an architecture to achieve 99.999% availability. Uh, 5 times 9 is generally a standard that is being requested from every organization for the replication of time. Or it can be also asked design architecture to avoid single point of failure, or active active versus is active passive architecture, etc. and etc. Like these are the all possible questions can be asked in interview. And the point is, in this we are going to learn some of the important concepts in system design, such as single point of failure, active active architecture, and active passive architecture. So these are the important concepts we are going to learn. Now, when we talk about single point of failure, what do we mean by it? So in system design, or whenever we are building an application or designing an application, so we have multiple servers. So all these servers are called as nodes. For example, this is the client. So we are calling it as a client node, or we can also call it as a client server. Then next come is we have a load balancer to handle the request. So this is also one node. Then we have the application, which means the application server where our actual application services are running. Another node. Okay. Then next, what do we have? We have the database layer. So this is another node of database. So all in all, we have this whole application in general with these all layers. And single node is the single server of component that we have added into our application. Now clients are in general is not, we cannot call it an application, the server. We cannot call clients as a server. So they are coming from browsers. So we are getting multiple requests from the clients, and it's been taken care by load balancer. Then load balancer decides where to redirect that request based on the load and availability of the applications. So we are going to learn more in deep about load balancer in the coming videos. So please keep a watch on for that. So for now, just understand load balancer is an component that manages the load per application, or yeah, per application we can say generally. So these are single nodes. Now the problem with single node is if something goes down, for example, if this database crashes, then our whole application will crash. So this is called as single point of failure. Okay. So definition wise, single node refers to the presence of single instance of any component in the system design that if crashes can cause whole system to go down. So such nodes are called as single point of failure. Now for this interview question, we have to avoid all these single point of failure nodes. For example, here we have application 1. So for first microservice 1, we only have one instance. So if this goes down, then our system where our application will not work properly. So what we do, we will increase the instances of this application. So we have now multiple instances of this microservice. For example, if one goes down, then there are two more that will serve the request. Same here. Now, is this load balancer itself single node? Yes. This is also a single point of failure. So similarly, we can increase the load balancer. Okay. Now the second question was design data resiliency architecture. So is it data resilient? No. Why? Because we only have one single database node, and if it crashes, it might take months to recover the data based on the size and complexity of the data we are saving. So we are not even sure that how much time it might take to get this database recovered. Okay, so this is all about single node or a single point of failure. Next is, let's talk about multi-node. So as name suggests, multi-node means multiple instance of the same component in system design, so that if one goes down, we have something running already that will handle the request, keeping our system resilient. Now in multi-node, there are two kinds of architecture, which is active-active and active-passive. Now let's understand each of them one by one. So what is active-active architecture? We have to understand about data centers. So what are data centers? See, data centers is nothing but the physical location where that whole application is deployed. So it can be, let's say, one is running in India and one is running in US. So we have two different data centers where whole of this setup is running. So this might be running in this specific data center. Okay. So these are two data centers. So this same application setup might be running in two different zones. This is, let's say, in India, and that is, let's say, in US, or it can be in different states of the same country. So because since we want to make our system resilient, our application resilient, so there is a possibility, let's say, if we only have one instance of the whole system running in some one region in one data center, and due to some natural calamity, calamity, it goes down, right? Or due to, let's say, fire broke out or server got damaged physically, then our system will go down, right? So to reduce that as well, to make it resilient in that matter as well, we, or all the organizations generally run their applications in multiple zones, in multiple data centers. So how the system will look in this matter? So clients will request, there will be a load balancer in the middle. So now client will be connected via this load balancer, and then this load balancer will decide where to send, and based on the load, of course, and then it will be redirected toward this. So now is it resilient? Most probably yes, because we have one load balancer here and we have two load balancers there. And you might argue that okay, this is one single load balancer among data centers, so yes, this is a single node, then we can increase the instances of the load balancer as well. So that is one thing. Okay, now what actually active architecture means? So in active architecture, so what we are generally talking is about the database. As you can see, we have now two instances of database running among across multiple data centers, and what we don't want is to have them different data. So first thing would be they will be in sync, and in active there is only one master database. Let's say this is the master one, and this one will be a replica, or we can also call it read only database, which means any write request coming either on either data center will will write on this specific database. On all the write requests will be redirected to this master database. However, this database is will be only used for read only purpose. So anything right new data came up on this master database, it will be synced in this replicated database, and if on data center second you receive any read only request, then it will be served via this database. You might wonder, like, does it only do write? No, it will also use for reading as well. So for read operations you can also use this one, but all the write requests will be redirected to this specific master database. So in active passive architecture, out of multiple data centers, there will be only one data centers that will be treated as primary, which in our case is this one. So name may change. They can say live database, they can say read write database, they can say primary, but we are calling it as primary. Now other data centers are always called as replicas. And one more thing about such database or data centers is we call it as data disaster recovery. So we use it for data disaster recovery. Means if this goes down in any case, in any scenario, then this replica database will become master database, and requests will be served as usual until unless our main primary data centers comes back up. Now, in general, the active architecture is not highly encouraged, but is also used majorly. But the problem here is, here we are not utilizing our resources to the fullest. If a user is sitting in India and he wants to do some write, then for him there is not a problem because the data center present in same country. But for some user sitting in US and wanted to do a write request, so due to the request redirection towards the Indian data centers, latency will increase. So this is one problem. Second is the resource is not utilized to the fullest because we are only using this database to read only. Now this database is up and free, but still we cannot utilize it to write. Now the one problem with this is with the database such as Oracle, MySQL, or Postgres, they are not multi-master, which means they don't allow multi-write operations in multiple instances of the database. So they allow multi-reads from replicas, but they don't allow read on replica as well. So we can improve the architecture for the disaster recovery read only. In which case we will optimize it up to some extent because we are now utilizing it to read. There is one more disadvantage of this architecture. In case of failure of our main data center, redirection of all the write requests will take some overhead time. So it may take 10 to 15 minutes, due to which all the write requests for that specific time will be dropped, and application operations will be hindered for that time. Now, as you might have guessed, like these problems are resolved by active architecture. So there are some databases that supports multi-master such as Cassandra by Facebook, now Meta. So now we take the same example of the same application in multiple zones. Now we take example of the same one. So now all the operations are possible on any of the data center. So both databases are now will be live database, or we can say primary database, means both of the databases will have the same permissions as the second one. Now the only part to note here, this synchronization part will be complex. Now why this will be complex? Because right now what we are doing, we are allowing both of the databases instances to have write requests simultaneously. So if, let's say, in db1 someone write something in row 1 and someone write something in database to row second, that would be easily synchronizable because they are different rows. Now in case of same row, I got edited in both the databases. This was row 1 and this was row 2. If same row get edited, updated in the database of both of the instances, then there will be conflict. So what does it mean? It means our active architecture will utilize all of our resources to their full capacity. However, there are some challenges that has to be worked on, which are synchronization issues and conflict resolution. So this is a different topic. I need to have a separate video for that. So I hope you understand this much about designing a high resilient system. And if you get this question asked, so we can definitely answer this with the concept that we have right now. And just keep in mind, if your application is very read heavy and write is not the main priority, then active passive will work wonderfully in that scenario. But in case of the write heavy applications, the active architecture will not able to scale and will have bottleneck in future. So for that we have to utilize active architecture while resolving this such issues. But there should be some database available which resolve these issues with the help of, let's say, change log, which both database maintain a change log and they share it with each other. So based on the timings, the conflict is resolved. So that's all for this specific video. I hope you understand the concepts. See you in the next one.